Hi everyone, this is Mr. Kerr. In this video, we're going to be looking at what happens when polyatomic ions vary. So what I have here is I've got two different polyatomic ions. At the top, I've got my chlorate, and at the bottom, I've got my phosphate. And we know that for each of these, we know the basic the composition of the polyatomic ion. So here it's PO4, so 4 oxygens with a charge of 3 negative. And at the top for my chlorate, I know I've got ClO3, so chlorine 3 oxygens, and I got a -1 charge. Now, the polyatomic ions vary quite a bit. So you don't always have the same number of oxygens. So for example, for the chlorate, I might only have 2 oxygens present instead of the 3. Well, what happens is when you have the 2 oxygens, you still end up with a negative charge. I should indicate that here. So still the same negative charge. The formula is different though. So I'm going to have ClO2 negative. So I can't call it a chlorate. So what you do if you're missing an oxygen, you have one less oxygen, you call this a chlorite. Similarly, with a phosphorus, if I have a phosphorus that has one less oxygen, only has 3 oxygens, I'm not going to call it a phosphate. I'm going to call it a phosphite. So the ite means one less oxygen. Now, the important thing to remember is these ions always have the same charge, regardless of the number of oxygens that they might gain or lose. And other times what might happen is you might even have this. You might have a chlorate that is missing 2 or has 2 fewer oxygens. So it's only ClO, still with the negative charge. Well, we can't call it chloride. We can't call it chlorite. So then what we do is we call this hypochlorite. So that indicates that you're missing 2 of the oxygens. And down here with the phosphorus, very similar. What you do is you look at the phosphorus, it only has 2 oxygens. So what we have here is instead of PO3 or PO4, it's PO2. It still has the 3 negative charge associated with it. But remember, we cannot call this phosphite or phosphate. This is called hypophosphite. Oops, forgot the I there. Phosphite. So the hypo and the ite indicate that this has 2 less oxygens. That's quite possible. That's about as far as you can go on this side. Now, sometimes what you might have is you might have a chloride ion that has an extra oxygen. So instead of the 3 it typically has, it's going to have 4 chlorines. It still has the same charge as all the other chlorate ions, or the variations of the ions. However, the formula is going to be different. It's going to be ClO4, same charge, and I can't call it ite, so what we do here, we write down the per at the beginning and call it perchlorate. So the per and the ate tells you that you've got 1 extra oxygen. And just like with the chloride, the phosphorus does the same thing. I could have 1, 2, 3, 4, 5 oxygens. And I'd still have the same charge, 3 negative. And my formula would be PO5. And I call this per phosphate. So 8 ending per to indicate that you've got 1 extra oxygen. So this is simple, the system that we use. So again, this would be like the quote-unquote normal in the middle, the typical polyatomic ion, and then you change the ending. If you got 1 less oxygen, be ite. 2 less oxygens would be hypoite, and if you have an extra oxygen, you have used the per-ate system. So this is what you have on your handout here. So again, here you got the regular, the typical polyatomic for chlorine, so chlorate. An extra oxygen would give you perchlorate. Missing 1 would be the ite. Missing 2 is hypoite. So it's a very, very simple system. So what I'd like you to do is I'd like you to complete this table with the appropriate terms for each of these ions. All right, let's see how we did. So for the typical polyatomic ion, you can use the 8 ending. If you have an extra oxygen, use per 8. You notice that all of these have the extra oxygen associated with them. If you're missing an oxygen from the typical, use the ite ending. So all of these have the ite ending. And if you're missing 2 oxygens, use the hypoite ending. So very, very simple system. So what I'd like you to do now is to add this as an extra feature at the bottom of your chart here. So I'd like you to do the following. So if you could draw the simple table to show the different possibilities for different oxygens that are present in the ion. So here, typical polyatomic ions have the 8 ending. If you have an extra oxygen, use the per H, so it'll be per carbonate, per nitrate. So you have to insert the name of the polyatomic in between. If you're missing an oxygen, you're going to have the ite ending. If you're missing 2 oxygens, then you use the hypoite ending. So again, if you can put this on your summary chart to help you remember how to do these derivatives. And we call them salt derivatives because we use these endings when the polyatomic is associated with a metal. And that's it.